Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
So, we don't have all the details about how the universe, our solar system, and its planets came to be. But one thing's for sure, Earth didn't just pop out of thin air. Scientists have recently made an intriguing discovery that suggests our planet may have formed way faster than we previously thought. You see, up until now, experts believe it took over 100 million years for Earth to take shape. The common belief was that lucky collisions with water-rich asteroids brought water to our planet. A recent study, however, proposes a whole new perspective. According to these researchers, there's evidence that Earth formed through the rapid accumulation of tiny pebbles, each roughly the size of your fingernail. In this scenario, our awesome planet emerged in only a few million years. And here's the mind-blowing part. They suggest that water being here isn't just some happy accident, but a natural result of the formation process. Now, this discovery has implications that go beyond Earth itself. If our planet formed quickly and water was an integral part of the process, it means the chances of finding habitable planets in other solar systems are way higher than we ever imagined. If we stumble upon other planetary systems with planets orbiting sun-like stars at the right distance, there's a good chance we'll find water there too. That's some nice intergalactic real estate that we might just be able to relocate to, should we ever get in trouble here on Earth. The old-school view was that planets slowly took shape through countless collisions over millions of years. According to that theory, water on Earth would have been a random stroke of luck, maybe caused by comets packed with water crashing into the planet during its later stages of formation. The new study introduces an alternative theory too. Picture this: a young sun surrounded by a disk where the planets are popping up. This disk is filled with tiny dust particles. Now, here's where it gets exciting. Once a planet reaches a certain size, it acts like a cosmic vacuum cleaner, swiftly hoovering up all the dust in its path. In just a few million years, this tiny planet grows into the size of Earth. This not only shapes our incredible planet, but guarantees water's existence too. As the planet gobbles up the dust, it also snags icy particles floating around in the disk. So, if we use Earth as an example, it suggests that whenever a similar planet forms, it's bound to have water naturally. There's no way for us to travel back in time and see for ourselves, so there are more theories about how planets are born. Let's dive into a different scenario called the core accretion theory. Picture a big cloud of dust twirling around in space. That's where the action begins. Over time, this cloud starts pulling in an astounding 99.8% of all the matter, eventually creating our sun right at the center of our solar system. Soon enough, solar winds join the party, bringing in lighter atoms like hydrogen and helium that are closer to the sun. But those heavier elements? The sun can't pull them in because, well, they're too heavy. So what do? They gather together and stick to each other, forming their own little planets. That's how Earth, Mars, Venus, and the gang got together to create round spheres. The heavyweights, like zinc and iron, sank to the middle, forming the core, while the lighter elements meshed on top, creating the crust. But wait, we can't forget about Jupiter. Its gravitational force and the Sun's were locked in an epic tug-of-war, perfectly balancing each other out. That's why we have that fascinating asteroid belt hanging out between Mars and Jupiter. Those poor asteroids never got the chance to become fully fledged planets on their own. This explains why the planets in our solar system are arranged the way they are. The inner ones, known as the terrestrial planets, like Mercury, Venus, Earth, and Mars, are closest to the Sun. They're made of denser stuff like iron, silicon, and aluminum. On the flip side, the gaseous giants, like Jupiter, Saturn, Uranus, and Neptune, are chilling on the outer edges of the solar system. These big celestial bodies are composed of lighter materials, such as hydrogen, helium, and methane. Now, let's take a trip to the outermost layer of our solar system, where the Kuiper Belt and the Oort cloud reside. These distant areas are home to ice bodies, space debris, and comets. While there may be plenty of them, they're relatively small and don't contribute much to the total volume of our solar system. The quest to understand planet formation doesn't end here. There's another mind-boggling mystery that's causing a stir among scientists: the existence of a celestial body dubbed the planet that shouldn't exist. Let's rewind a bit. Astronomers have been on a roll with exoplanet discoveries, and we've already spotted over 4,000 of them. Most of these exoplanets resemble the gas giants in our own solar system, like Jupiter and Saturn. Do you know why? It's because those massive exoplanets close to their stars are the easiest to detect. But here's the twist. A new study suggests that there's a whole bunch of Jupiter-like exoplanets just waiting to be found, and they're probably hanging out nearby. This impossible planet goes by the impossible name JG3512b, and it's remarkably similar to Jupiter, only orbiting a tiny red dwarf star. This discovery shook things up because it defied the most popular theory of planet formation. According to the prevailing ideas, it should have been impossible for such a giant planet to form around such a small star. So, what's the deal with this impossible exoplanet? Well, it turns out that core accretion, the theory we discussed earlier, can't explain its existence. According to this theory, the mass of the debris disk surrounding a young star should be directly proportional to the star's mass. But here we have a star much smaller than our Sun hosting a planet that should be way too massive for it. Something doesn't add up. Either the original debris disk was insanely enormous compared to the star, or core accretion didn't play out as expected in this particular planetary system. We've established that when talking about the Earth's formation, there's still much we don't know. But hey, we've come a long way. Back in the 18th century, a philosopher named Immanuel Kant had his own intriguing theory about planets popping up in the universe. He based his ideas on Newton's law of gravity, but added his own little twist. Kant believed that the universe started with an original substance made up of super cold, solid particles just chilling out. Then, thanks to gravity, these particles began colliding and heating up. And you know what happens when things collide, right? They get hot. According to Kant, this cosmic twirling and heating up caused some serious forces to come into play. It's like when you spin around so fast that you feel like you're about to take off. These forces led to the formation of rings of matter, like cosmic hula hoops. And as these rings cooled down, they transformed into planets and satellites. Now, not everyone was convinced by Kant's wild idea of planet formation. Critics raised their eyebrows and started questioning the whole theory. They pointed out that Kant failed to address the origin of this primordial matter. Where did it come from in the first place? Moreover, he overlooked the source of energy that propelled these particles from a state of cold stillness to a frenzied cosmic dance-off. As creative as his theory was, it soon faced dismissal in the scientific community. In short, they said, "This can't happen." Nevertheless, Kant's theory was still a step forward compared to older beliefs about Earth's origin. Take the ancient Egyptians, for example. They believed that primordial spirits, often depicted with frog heads in their native artwork, were responsible for our planet's existence. Why frogs, you ask? Well, they associated the first substance in the universe with water, and frogs just love humid environments. So, out of that initial water, a primordial hill emerged, followed by the elements of air and moisture. Ribbit.
For more than 170 million years, they dominated our planet. From small creatures that were only a few feet long to some of the biggest animals to have ever roamed the land. Let's admit it, the age of dinosaurs gave us some pretty scary predators, like T-Rex, Spinosaurus, the Velociraptor, Gigantosaurus, and so many others that made the rest of the animals shiver in fear. But everyone talks about dinosaurs all the time, so it seems like no other scary beasts ruled the animal kingdom besides them. But check out these reptiles. They dominated the prehistoric world for more than 120 million years, way before dinosaurs. But even before them, nature had to create the first true reptile. There was a swampy, wet era when many new groups of plants grew into great forests in tropical deltas and swamps. Trees were not like those we see today. They were mostly horsetails, club mosses, and the first seed-bearing plants called gymnosperms. It was during this time that the first peat bogs formed too. The most common creatures on land were prehistoric amphibians, which evolved from fish that were basically sick of being in the water all the time. So they decided to take a walk to see what was happening on dry land. Those early amphibians had a problem though. They depended on water to stay well hydrated and lay their eggs, so they couldn't go too far from lakes, rivers, and oceans. At least not until a special creature called Hylonomus evolved. With its 4 legs and scaly skin, we're looking at our best candidate for the first true reptile. These features help the animal move away from the water and explore dry land. As plants were intensely growing back then, they produced more and more oxygen, which probably helped these complex animals, such as our buddy Hylonomus here, develop. Let's rewind the story a little bit. 300 million years ago, Earth was hotter and drier, which was not that good for amphibians, but was great news for small reptiles like Hylonomus. These reptiles were able to regulate their body temperature and lay eggs on land, so they didn't need to stay close to water. That's when they started evolving into different groups. One was called pelycosaurs, and they lived in different ways. Some ate plants, while others preferred meat. You might recognize the most famous one from their group, with a big sail on its back. People often mistake this creature for a dinosaur. Over time, some pelycosaurs evolved into the so-called mammal-like reptiles we called therapsids. Therapsids had stronger jaws and sharper teeth, and some could stand upright on their legs, unlike their ancestors that moved more like lizards. Take gorgonopsians, one of the top predators of their time that even dinosaurs wouldn't have liked to face. In a way, they were similar to mammals because they were probably endothermic, which means their body had a constant internal temperature. They had long legs, good for running and hunting. They mostly lived in southern Africa, but their fossils were spread across Europe and China too. Oh, the joys of times when continents were joined together. Top predators had no limits back then. Gorgonopsians went after different animals, especially those armored ones related to turtles. That's the type of chase I wish I had the chance to see. Some gorgonopsians had really big skulls, almost 1.6 feet long. Scientists think some of them may have hunted in groups, but we're not sure about that. One specific gorgonopsian was about 3.2 feet long and had a skull that looked like a wolf's face. It had long, sharp teeth in both the lower and upper jaw, similar to the saber-toothed cats. You may have heard about these from the Ice Age. Such teeth were good protection in such messy, insecure times. And we need to mention the Permian extinction. About 250 million years ago, 90% of all species, including animals in the seas and on land, as well as most of the trees, disappeared from the face of the Earth. Why did this happen? Scientists are still not sure. One theory says it may have been a massive asteroid impact, while another theory claims the spread of toxic levels of carbon dioxide in the ocean erased marine life. There's also some evidence of massive volcanic eruptions around the same time as the extinction. These eruptions could have released gases into the atmosphere, causing acid rain and making our home planet cooler. And all these things might have affected life in the ocean and reduced diversity in animal and plant kingdoms in general. Whatever the reason for the worst mass extinction in the history of our planet was, the rhapsids managed to go through all these troubles and survive. Not only that, they spread out and evolved into many different groups. Some of them even got cool features that made them more similar to mammals. Fossils show some reptiles had fur and maybe even warm-blooded metabolisms. They may have had wet black noses, like dogs, but it would be tricky to take this one for a walk. One of them might have given birth to live young, which is a characteristic of mammals rather than reptiles. Unfortunately, the rhapsids eventually went extinct and ended up being replaced by archosaurs, which were finally the ancestors of dinosaurs. But not all of them disappeared. Some survived alongside dinosaurs for millions of years. That probably wasn't an easy task. They continued to evolve and eventually became the first prehistoric mammals. But moving back to the pre-dinosaur era. Wait, what's that buzzing sound? Oh wow, the biggest insect ever! Yup, it's Meganora, a giant dragonfly that lived about 300 million years ago. Its wingspan could be more than 28 inches. They were predators and would mostly go after other insects, but I'm not sure I'd feel safe if they were flying around these days. Imagine getting back from a camping trip and instead of scary stories about terrifying beasts wandering in the woods, you only have one where an insect pushed you down and stole your stuff. And it's really weird these insects could grow so big during the period when they lived. One idea says it's due to higher oxygen levels in the air at that time. A lot of carbon ended up trapped in plants, so the oxygen levels were higher. Insects breathe in a different way than most animals. They have these special tubes called trachea that deliver oxygen directly to their body tissues. But this system is not very efficient for bigger insects. Oxygen moves slowly through the trachea, so the tissues in the middle of big insects wouldn't get enough oxygen to survive in today's world, where there is less oxygen. And for that, I'm very, very happy. And what about Arthropleura, a giant millipede that lived more than 300 million years ago? It was one of the biggest invertebrates ever discovered that could grow up to 8.5 feet, similar to a small car. Now that's a ride I wouldn't like to take. And once again, lots of oxygen probably gave a chance to these creatures to grow up to be the biggest of their kind. Arthropleura weighed around 110 pounds, which would be similar to a big dog, and it used to roam the beaches of ancient England. Well, okay, I'm fine. I'll find a pool somewhere. And their fossils showed us where they lived. Many used to think they preferred coal swamps, but newer research tells us they mostly lived in open woodlands. They could get a lot of food there, like seeds, nuts, and of course, some other small innocent animals. These creatures existed for about 45 million years and went extinct more than 250 million years ago. No one knows for sure why they disappeared, but some scientists believe they may have been competing with reptiles that eventually replaced them. And this slowly led to the rise of our beloved dinosaurs. So we're moving to 66 million years ago in the world where dinosaurs lived. What are we doing here? We're just watching these giant reptiles and waiting for one of the most massive disasters on our planet to strike. Right now, a giant asteroid bigger than Mount Everest is flying at a tremendous speed, exceeding the speed of sound 40 times in the direction of our planet from the depths of space. It passes through our atmosphere, heats up, and hits the coastal part of the island of Yucatan, which separates the Gulf of Mexico from the Caribbean Sea. The enormous release of energy destroys all living things in the area, on land and in the ocean. The air over the island is filled with smoke and ash. Yucatan Island has taken the brunt of the blow. The blast wave instantly turns the green territory into a giant, lifeless crater. The asteroid fell at the wrong time. By the moment of the catastrophe, Earth had already been undergoing devastating changes. Continents were separating from one another, and some volcanoes were waking up, pouring lava onto the ground. Dinosaurs had been almost on the edge of extinction, but the asteroid shaped their fate. Now, Yucatan looks like a giant funnel of melting rock. There are no more dinosaurs here. But what about those animals that were far from the crash site? The noise from the explosion was so loud that pterodactyls hanging out far from the crater flew up into the sky in fear. A Tyrannosaurus got distracted from its hunting and ran away as far as possible, along with Triceratops. But somewhere, even further, in mainland Mexico, ancient lizards continued to chew grass and run around fields. They did notice a bright flash, but didn't mind it. They didn't even hear the sound of the explosion because the sound wave dissipated in the air. No blast wave, no earthquake, and no meteor shower. Dinosaurs continue with their lives. Unfortunately, not for long. Most dinosaurs would have survived if the meteorite had fallen in a field, ocean, or any other place. Perhaps today, we would see them in nature reserves, but the meteorite fell in the most unfavorable place. According to studies, the giant rock had a 1 in 10 chance to destroy dinosaurs, and it took this chance. It wasn't a soft landing. The stone didn't slip on the ground, but hit the rocky terrain like a giant hammer. The catastrophe wasn't limited to a blast wave and a crater. The asteroid fell into large stalks of flammable materials. Simply put, the space rock got into a giant vat of combustible substances. This provoked a drop of millions of tons of soot and ash into the air. The fire quickly spread throughout the island, emitting black smoke into the sky. Dinosaurs living hundreds of miles away from the site are getting nervous. Feelings of anxiety are growing. Their inner instinct of self-preservation signals that disaster is coming. The sky becomes gray and darkens. Black clouds cover the sun and reflect the light. However, these are not just regular clouds, but volcanic ash. The asteroid fell at the most destructive angle. It also hit the coastal part, so the destruction reached the seabed filled with sulfuric acid. and now it's all coming out. Toxic fumes get mixed with incandescent ash, soot, and metals the meteorite contained. A fiery hot cloud emits acidic smoke that is very harmful to health. And this cloud, driven by the winds, grows and stretches all over the continent. It's getting cold on the ground. Plants, grass, and trees are quickly withering. The green valley, saturated with life, becomes gray and lifeless, which leads to an imbalance in nature. Most dinosaurs can't get fresh grass and leaves. This problem also affects predatory reptiles since the number of herbivorous lizards significantly decreases. Animals start to freeze and starve. They move away to search for some food and find a warm place, but it's too late because a poisonous firestorm is approaching them quickly. Dinosaurs try to hide in burrows and caves. Some lizards are looking at the sky, which is getting darker each second. A tiny sparkle slowly falls from a black, fiery cloud. This is a particle of hot ash. It drops to the ground, touches the dry leaves, and sets them on fire. Millions of such particles fall to the ground. The forest flares up like a match. The smoke from the burning trees rises and becomes part of the expanding ash cloud. The more the fire spreads, the larger the ash cloud becomes. Sulfuric acid vapors mix with molten metal particles and fall to the ground as poisonous droplets. Acid rain corrodes vegetation and poisons the soil. Flying lizards rise into the sky and enter the center of the firestorm. Dinosaurs on the ground are running from the forest towards the water, but it's impossible to escape from the apocalypse. The scale of the disaster is increasing exponentially. While acid rain and firestorms destroy one part of the continent, the coastal side faces another problem. The fall of the meteorite caused a giant tsunami. It hits the shore and floods large areas of land. After the massive explosion, the first wave forms. It could quickly destroy modern-day New York. A series of smaller waves, the size of a 5-story building, sweep across the Atlantic Ocean and the North Pacific Ocean. Giant tsunamis are not so scary for deep-sea dinosaurs, but the poisonous cloud poses a danger to them. Particles of sulfur and ash cover the sky above the water surface and bring down poisonous rain. Seaweed and phytoplankton don't survive it. Thus, millions of fish face the threat of famine. This causes huge problems for the whole food chain in the ocean. Giant sea lizards can't survive either. The meteorite created a domino effect that put the entire continent under threat of extinction. A few weeks have passed. The ashes have settled and cooled down. The fires are over, and the air has become cleaner. The sun is finally peeking through the clouds. But the planet looks different now. Giant lizards don't exist on the planet anymore. Green forests have turned into gray fields. Fortunately, not for long. The seeds of plants and trees have survived the apocalypse and are now blooming with renewed vigor. Nature is filled with colors again. Little creatures similar to rats have been hiding in the ground and have also survived. And now they finally get out to continue spreading life. It wasn't firestorms, tsunamis, fires, and lack of sunlight that destroyed the dinosaurs. The primary damage to the world at that moment was the disruption of the food chain. All big herbivorous dinosaurs and giant toothy monsters lost their food sources. Small animals and some flying dinosaurs survived to further evolve into modern birds and mammals. Large animals, the size of a rhinoceros, appeared 15 million years after the disaster. Tens of millions of years passed since that moment, and then humanity appeared. Thanks to modern technology, we've discovered the reasons for the destruction of dinosaurs. We don't know every detail, but we have a common picture of those events. And the scariest thing is that if the same asteroid fell again into some explosive terrain, we wouldn't be able to do anything about it, and our remarkable technologies wouldn't help much. Yes, we might disperse ash clouds and extinguish some fires, but it would be insignificant. Floods, fires, and acid rain would make life in big cities unbearable. the only thing that would help us survive could be underground bunkers and other reliable shelters. But how to survive the famine that would come after the destruction of vegetation and crops? We are developing and improving technologies that can protect us from asteroids, like lasers or space rockets with explosives. But even if we destroy one big rock, it might tear into 1 million pieces. Some will burn up in the atmosphere, and some will fall on the planet in the form of a meteor shower. Anyway, we'll face huge natural disasters. Therefore, all we can do now is hope that no rock from space will come to us.
So scientists have this idea that some exoplanets, which are worlds outside our solar system, might be water worlds. They orbit their distant stars, covered by global oceans. Even better, some experts claim that our Earth was once the same, a vast expanse of the ocean, and just a bit, if any, visible dry land. At the moment, water makes up 71% of Earth's surface. Our planet experiences continuous movement of water. First, water evaporates, rising from the ocean surface to the atmosphere. Then rains fill lakes, rivers, and underwater reservoirs. Eventually, all this water ends up in the ocean again. Water also plays an extremely important role in the processes happening below the ground. For instance, water content in magma determines how explosive a volcano can be. Anyway, one of the most burning questions about Earth's water is, where did it all come from? It's very unlikely that our planet was simply born this way. The thing is, water has a way lower condensation temperature than some other substances, like silicates or iron. These materials compose the terrestrial planets in the solar system. In the early history of our planetary system, the region where Earth formed was too hot for the oceans to condense at the same time as our planet appeared. So, there's this idea that water appeared on Earth when melted meteorites hit the surface of our planets. Well, scientists disagree. Researchers analyzed some melted meteorites that had been hanging around in space since the formation of the solar system about 4.5 billion years ago. They discovered that those space rocks had extremely low water content. Even more surprising, they were among the driest extraterrestrial materials ever found and examined. In other words, once they melted, there was essentially no water left. These results were very important, since they helped scientists rule out melted meteorites as the primary source of water on Earth. Plus, we can say that this revelation was kind of eye-opening. Imagine the unlikely conditions that aligned to make our planet habitable. Getting water and developing surface oceans on a planet so small and so close to the Sun is a great challenge. If Earth had formed just a tiny bit closer to the Sun, our planet would have been much hotter, and all the water would have most likely evaporated. If it had been farther away from our star, Earth would have turned out to be much colder, and the water would have probably frozen into ice. The team of scientists managed to analyze 7 melted meteorites that had crashed into Earth. Those must have splintered from at least 5 space objects known as planetesimals that later collided to form the planets in our solar system. These planetesimals took part in something known as melting. They got heated up as a result of the decay of radioactive elements in the early solar system. This caused them to separate into layers with a core, mantle, and crust. Plus, the heating and melting of planetesimals apparently led to near total water loss, regardless of how much water they started with. As for meteorites, some of the samples arrived from the inner solar system where our planet is located. The conditions here are relatively warm and dry, so it's no wonder the meteorite samples didn't contain much water. But a few samples were from the colder outer reaches of the solar system. That's from where the water is believed to have come to our planet. But if this water hadn't been delivered by meteorites, what kinds of objects could have carried it all the way across our planetary system? There's one more theory, though, that hydrogen inside our planet played an important role in the formation of the oceans. At the same time, these two ideas are not mutually exclusive. Water could have been delivered to Earth by impacts from some space bodies, like asteroids from the outer edges of the asteroid belt, spanning between the orbits of Mars and Jupiter. And some amount could also appear inside our planet. There's also a theory that claims that Earth gradually grew by accumulating icy planetesimals about 4.5 billion years ago. At that time, it was still only 60 to 90% of its current size. According to this theory, Earth managed to retain a certain amount of water in some form throughout the process of accumulating its mass, and as a result of large impact events. It sounds quite plausible. The examination of the chemical composition of lunar samples brought to Earth by the Apollo 15 and 17 missions indicated that water had already been present on our planet before the Moon was formed. So far, all these ideas remain just theories. At the moment, we don't know for sure how water appeared on Earth. What we do know is that there are many other space bodies that have water in this or that state on their surface, or under it. Let's start with our dear Moon. On Earth's natural satellite, water can be found all over the surface, but it's probably not the water you imagine. You won't find pools of liquid water there. On the Moon, it's mostly ice. Some places have more water than others. For example, the poles of the Moon are regions that never get any sunlight. That's why they're extremely cold, and there's a lot of ice there. Plus, the ice in these areas is often mixed with the lunar soil and hidden deep below the surface. Then there's Jupiter's moon Europa. Astronomers consider this world to be one of the most promising places in the solar system to search for new life forms, all because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, the temperature, pressure, and chemistry are far different on Europa. Scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water reservoirs on Europa are, or how long they need to refreeze. Enceladus is the sixth largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. Wait, we should try that. Never mind. When the Cassini space probe first arrived at Saturn, astronomers thought that Enceladus was going to be a frozen ball of ice. But then they saw plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a massive ocean between the moon's rocky core and its icy shell. If you've been imagining Mars as an extremely dry place, you need to listen to this. Scientists think there could have been a lot of water on Mars in the past. What makes them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that can only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet. It's true that Mars's atmosphere is too thin for this water to stay in its liquid form on the surface of the planet. But under the surface, it's a different matter. You can find water in Mars's polar regions, but the only place where this water is visible is at the North Polar Ice Cap. Sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. Since we know for sure there is liquid water on Mars, could we possibly use this water during the human-operated mission to the red planet? If we manage to do it, spaceships coming from Earth wouldn't have to bring their own water. It would make the cargo way lighter, which, in turn, would decrease the cost of the mission. We would just need to take enough water to get to the red planet and bring along the equipment needed for filtering Martian water to make it drinkable. Well, it sounds simple enough.
It's becoming colder by the minute. The temperature drops below zero very quickly. And although there's no snow, the cold is becoming unbearable. Hoarfrost appears on the ground, the grass, and the trees, and ice forms on bodies of water at an incredible rate. Shivering people all over the planet raise their eyes to the sky, and their jaws drop in disbelief. The sun has become twice as small as it used to be. It now looks like a distant speck, and it won't be able to heat the Earth any longer. But the worst thing is, there's a huge blazing rock coming right at the horrified spectators from the sky, and the impact with that thing will undoubtedly do a lot of damage. Okay, let's go back to our objective reality. The Earth is exactly in the sweet spot of our solar system. It's neither too close nor too far from the Sun, making the temperature on our planet not just tolerable, but rather pleasant. Scientists often call Venus, the second planet from the Sun, our Earth's evil twin, because it's so hot and inhospitable that no life is possible on it. Of course, there are thick clouds in its atmosphere that rain acid, and the greenhouse gases raise the temperature on the surface to unbearable values. But even if Venus didn't have those, nothing would still be able to live there because of the proximity to the Sun. If there was any liquid water, it would evaporate too quickly, leaving life no chance to develop. On the other hand, Mars, going next in line after Earth, is a bit too far away from the Sun, which makes it cold and lonely. The temperature on its surface is below freezing, and it never warms up enough for water to stay liquid for long. That's not to mention the lack of atmosphere on the red planet, the element that provides the Earth with breathable air. So, if our planet shifted closer to or farther away from the Sun, its temperature would either rise or fall respectively. A few hundred miles wouldn't make much difference. The circling of Earth around the Sun is uneven anyway, and we constantly get nearer to our star or fly a bit away from it. The distance that would matter is measured in millions of miles. And yeah, just like I showed you at the beginning of this video, we'd see the Sun a lot smaller than we do now if we went that far. The temperatures might not fall at the exact moment of the shift, as there would still be some warmth left. But in the following winter, our planet would probably stay cold forever. The oceans would be covered with ice, and the overall sea level would drop. And ultimately, the ice would reflect more of the Sun's heat back into the atmosphere and space, not allowing the surface of our planet to get the necessary warmth. And more ice means less water vapor in the atmosphere. Water vapor captures heat too, creating clouds. So the colder it is, the less rain. The cold and the lack of rain would not let any plants survive for long. So the areas of icy and barren landscape would grow fast, leaving only the areas along the banks of rivers intact for a while. After some time, the rivers would stop running too, either frozen or dried out because of losing their sources, lakes and seas, which would, of course, freeze as well. Any life dwelling near them would disappear. Plants first, and with them, everything else, since plants produce both food and breathable air. And with that, the Earth would become a frozen wasteland. As for the giant blazing rock I mentioned, it was an asteroid coming from outer space because of the shift of our planet's orbit. Jupiter, the largest planet in our solar system, acts as a natural shield for us against space rocks. It has a huge mass, and most asteroids flinging from outer space get caught in its gravity and fall on its surface. There's no life possible on Jupiter, and its surface is gaseous, so asteroids tend to disappear in it without a trace. Still, some manage to get past Jupiter, where Mars comes into play. It also contributes to our defense by holding the asteroid belt between itself and Jupiter in place. The two planets' combined mass creates a gravitational field that doesn't allow the asteroids from the belt to fly in random directions, hitting everything in their path. If there was no Mars between us and the belt, we'd be used to meteor showers almost more than actual rains. Say the Earth has replaced Mars in its orbit, and now we're hundreds of millions of miles farther away from the Sun. The mass of the Earth is more or less similar to that of Mars, so the asteroid belt is still in its place. The temperatures will still fall though, and life will soon go extinct. But if Mars stayed where it is, and the Earth just shifted away, it would be a recipe for disaster. There's no chance the planets would orbit the Sun at the same rate because their mass is not equal. At some point, they would collide with each other. Taking their speed into account, they'd both crack and shatter, perhaps creating another asteroid belt in our solar system. It would be no more hopeful for us if the Earth decided to jump closer to the Sun. Apart from the star seeming more like a giant, pitiless blazing ball in the sky, its heat would melt the glaciers on our planet, making sea levels rise abruptly. The water would flood major parts of the continents, and more surfaces of the planet would be covered with water, which means more heat absorption. That would bring about a further rise in the temperature. Also, those large bodies of water would evaporate like crazy, releasing tons of water vapor and carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that absorbs heat, and so does water vapor. Together, they would trap more and more of the sun's warmth, creating thick, roiling clouds in the sky, almost like on Venus, but without the acid. And that thick blanket of clouds would also contribute to heating the surface of our planet. In the end, the entire Earth would heat up so much that life on its surface would become unbearable for most. Only the sturdiest of creatures would be able to survive temperatures so high, those that dwell in our deserts, for example. Despite the rainfall, which wouldn't cease as in the cold scenario, plants would still have difficulty adapting to the new and hot environments. The ones in the cooler regions of the planet would be the first to wilt and go. But then, plants from the moderate and finally tropical climes would also give up. And, yet again, the Earth would turn into a barren ball of rock, only this time an overheated one rather than frozen. Our planet's distance from the Sun, its tilt, its speed of rotation around its own axis, its orbit around the Sun, and even the presence of the Moon in its skies, all of that is crucial for life on Earth to exist. For instance, if the planet wasn't tilted relative to the Sun, it would be unbearably hot on the equator and impossibly cold at the poles. The seasons would also stop changing, dividing the Earth into strips of endless summer and winter. Our planet is heated up evenly from all sides, with the current tilt and rotation, like you would roast a barbecue. It turns to the Sun with one side to warm it up, while the other cools down during the night. Were there no change of night and day, we'd probably only live in some areas of our planet where constant, never-ending twilight would be. Just imagine our life without those beautiful sunrises and sunsets. Maybe we'll just let it stay as it is, okay?
Hop on! I've prepared a tour around Earth's fellow planets. Let's start with Mercury, the smallest planet in the solar system. During the day, the temperature on the surface of this planet can reach 800 degrees Fahrenheit, and during the night, it can drop to negative 290 degrees Fahrenheit. The temperatures here are so extreme because the planet has no atmosphere. Instead of it, Mercury has a thin exosphere. That's one of the reasons why Mercury is not habitable. The temperatures and solar radiation are too extreme for any organism to survive there. Now let's imagine there's a way to live on Mercury. Then what would life there look like? Mercury's surface resembles that of the Moon. Over time, meteorites left lots of marks on it. Unlike the Moon's surface, Mercury is grayish-brown. Now look up. The Sun on Mercury would appear almost 3 times as large as it does on Earth. The sunlight would be almost 7 times brighter. I wonder what type of sunglasses people would wear if we lived there. Can life appear on this planet in the future? Don't get your hopes up, it's very unlikely. Now, how about landing on Venus? You might think the hottest planet in our solar system is Mercury since it's the closest to the Sun. But in reality, this title goes to Venus. What is it that makes Venus boil? The biggest reason is its atmosphere. It's made up almost entirely of carbon dioxide. The atmosphere is so thick that it leads to the planet warming up non-stop. Basically, the gases in the atmosphere prevent thermal radiation from leaving Venus. So, the planet simply can't cool down. The water on its surface constantly turns into vapor. If the surface of Venus was food, then its atmosphere would be the microwave. That's why the temperatures in this world can go up to 870 degrees Fahrenheit. what would it be like to live on Venus? On Earth, seasons change because of the planet's tilt, but Venus doesn't experience any significant changes throughout the year. Things are pretty constant at night and during the day too. And what about the view of the sky? The clouds on Venus appear yellow or bright white. They're mostly made of poisonous sulfuric acid, but then why does Venus appear reddish-orange when you look at it from Earth? Talking about the true colors of planets can be a tricky business. The hue of a space body might be different when you look at it from another planet. If we traveled all the way to Venus, a reddish-brown surface would welcome us. The molecules of carbon dioxide and sulfuric acid block sunlight coming into Venus's surface, hence the reddish-orange color of the planet. Oh, and did you know that Venus is often called Earth's twin? Both planets are nearly equal in size. Both have relatively young surfaces and thick atmospheres with clouds. Plus, the orbit of Venus is also the closest to Earth. That might raise a question about the possibility of life on Venus. I'm sorry to break the news, but nope. Venus is not habitable. The next destination is Mars. Unlike Venus, Mars has seasons due to the planet's tilt on its axis. It also has a secondary seasonal effect caused by its highly elliptical orbit. The southern hemisphere has colder winters and hotter summers than those in the northern hemisphere. The average temperature on Mars is negative 80 degrees Fahrenheit. But temperatures can also range from the poles to the equator, and they can change very dramatically within a single week. Still, not that bad compared to the previous two planets, huh? Is Mars habitable? The number one thing a living organism should worry about here is space radiation. Earth has a magnetic field and a thick atmosphere to protect its surface from radiation. Mars has neither. The planet's gravity is 1/3 of Earth's. So, weaker gravity and a thinner atmosphere make it harder for any living being to survive on the red planet. In 2013, NASA reported an ancient freshwater lake that could have been a hospitable environment for microbial life. This is evidence now that liquid water once flowed on Mars. This confirmation suggests that Mars could have had the necessary environment to support life. But what happened to the water on Mars? The most popular explanation is that the planet's atmosphere became too thin and cold to keep liquid water on Mars's surface. The disappearance of water might also be related to the loss of early magnetic fields. Or the reason might be the red planet's size. Mars is probably too small to keep water. So, for now, Mars is not habitable. But, scientists keep sending missions to Mars. Maybe they'll find some new information. Let's wait and see. Now, Jupiter. Have you ever wondered what it might be like to live on the biggest planet in our solar system? Jupiter's environment is an unlikely place to support life. The temperatures on this planet and its composition are too extreme for any organisms to appear there. Jupiter has layers of gas, mostly hydrogen and helium. These gases fill the entire planet. Quite literally, there is no solid surface on the planet. Gases go all the way to the core, below the surface. They become liquid and turn into plasma because the atmospheric pressure there is way more intense than any place on Earth. To put it into perspective, an organism on Jupiter has to resist 1,000 times more atmospheric pressure than it would on Earth. Can a living being survive in such conditions? Unlikely. Jupiter is completely uninhabitable. But hey, have you heard that its moon Europa might be a possible habitable zone? Change of scenery. Saturn. It's the second largest planet in our solar system. Like Jupiter, Saturn is a gas giant ball mainly consisting of hydrogen and helium. What about temperatures on Saturn? It's freezing. Plus, there are extremely powerful winds there. The winds in Saturn's upper atmosphere reach the speed of 1,600 feet per second. Let's compare them to storms on Earth to have a better understanding. The strongest hurricane ever recorded on Earth was moving at 350 feet per second. So the answer to the question, is there life on Saturn? Seems pretty obvious. Life, as we understand it, doesn't exist there. The next stop is Uranus, one of the largest ice giants. Uranus's atmosphere is dominated by ice, but it's not the only reason that causes the planet's blue color. It's also the methane in the atmosphere. It absorbs red light and reflects blue. The same goes for Neptune. Uranus is the coldest planet in the solar system. The temperatures there can be as low as negative 371 degrees Fahrenheit. Life on Earth needs sunlight to get energy, but there's nothing on Uranus that can produce any energy for life forms to thrive. The bottom line is Uranus doesn't have the environment to sustain life. Heading for Neptune, the second ice giant. What is there on the planet furthest from the Sun? Obviously, it's incredibly chilly. There's neither a source of energy that bacterial life can exploit, nor a source of liquid water. Currently, scientists believe it's unlikely to find life on Neptune because of such unfriendly conditions. So, what makes our planet so livable? And I'm not just talking about human life, I mean any living organisms, even microbes. Life requires very special conditions to exist. All living beings need some sort of food, water, and the right temperature to develop. The atmosphere is a vital element. Humans, for instance, need oxygen to breathe, and they can only survive in temperatures that aren't extremely hot or cold. Another thing is gravity. All the other planets I've mentioned don't have exactly the same conditions as Earth. Life there would probably be different than what we have here. All living beings on Earth have adapted to our atmosphere, and life forms elsewhere would need to be able to survive in that planet's conditions.
In July, when we're about 94 million miles from the Sun, the world is about 36 degrees Fahrenheit warmer overall than in January, when we're 3 million miles closer. This is because there's more dry land in the northern half of the planet than the southern half, and land tends to heat up more than water. During the northern summer in July, more land is heated up than in January. So the planet gets a little warmer at this time, even though we're further from our source of heat. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look the moon upside down through your legs. A day on Venus is longer than a year. It takes the planet 243 Earth days to rotate around itself, and only 225 Earth days to make a full circle around the Sun. Around 5 million years ago, the supermassive black hole at the center of our galaxy launched a star from itself, and it's now traveling through the Milky Way 10 times faster than any other star out there. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface showing that it's getting smaller. After more research, they found out that Mercury hasn't finished cooling down yet. The Earth and the Moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The Moon creates tides in the Earth's oceans. They pull back at the Moon and make it speed up. This in turn moves the satellite to a higher orbit. In prehistoric times, the Moon was way closer to our planet than it is now. Luckily, we aren't going to lose the Moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the Moon away with such a force. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because it orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? Everything on Earth and everything people have managed to see in space with the help of telescopes and other instruments, is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It got dubbed dark energy. Cold welding is a phenomenon in space when two pieces of the same metal join together without any trouble and heat. About 700 million years ago, a mysterious event that occurred may have turned Venus into the place it is now. Admittedly, astronomers can't see the surface of the planet directly because it's covered with dense layers of thick clouds. But space missions that have been sent to the hot planet found that Venus is peppered with fire-breathing volcanoes, massive mountains, countless craters, and gigantic lava plains. The temperatures on the planet are so incredibly high that they could melt lead, and the atmospheric pressure is so immense that it would instantly crush any living being reckless enough to set foot on it. If that's not enough, the atmosphere of the planet is filled with noxious clouds of sulfuric acid, which smells worse than rotten eggs. Carbon dioxide, the main component of Venus's atmosphere, along with the infamous sulfuric acid, create a powerful greenhouse effect. As a result, the lower atmosphere and the surface of the planet are some of the hottest places in the whole solar system. Neutron stars are the size of a small city, yet their mass is about 1.4 times that of the Sun. They're formed when massive stars die and their cores collapse in on themselves. The core continues to press in on itself until all the electrons are essentially crushed together, leaving only neutrons. This makes neutron stars one of the densest objects in the universe. In fact, a single teaspoon of neutron star material would weigh 1 billion tons. Of course, getting this sample and delivering it back to Earth might be a difficult task, since the gravity on a neutron star is 2 billion times stronger than the gravity on our planet. Because of the effect the moon has on Earth, our planet is gradually rotating slower and slower, and I mean very gradually, at around 17 milliseconds every 100 years. So, it will take 140 million years before the world can add a single extra hour to its day. But that also means that when the dinosaurs existed, there were only 23 hours in a day. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several 100 million years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. The newest scientific theory claims that Venus could have had a pleasant, stable climate for billions of years before something went wrong. Astronomers did thorough research and built a model of a virtualized Venus-like world. This model demonstrated that for most of its history, the hot planet had oceans with liquid water, adequate temperatures, and stable tectonic plates. In fact, the planet resembled Earth as it used to be at the beginning of its life. Scientists suppose that this period of Earth-like development could have lasted for more than 3 billion years. Saturn is a planet with winds that travel at more than 1,100 miles per hour at the equator. It's also the planet with the most prominent rings. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure becomes, and hydrogen becomes liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core, with hydrogen and helium surrounding it. On the other hand, even if it is made up of rocky material, the core can still be liquid. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique systems of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. The sky might appear pretty peaceful as you look at it from Earth, but the Milky Way is headed for a massive collision with the Andromeda Galaxy. 4 billion years from now, you can set your alarm. These galaxies will meet, and neither will survive. Stars will be scrambled, and constellations will be undone. Eventually, the two giants will merge and form an elliptical galaxy. But according to National Geographic, our Sun and Earth will survive. Any life forms on Earth will be treated to a splendid sight as the galaxies come together.